This video will discuss percents, and I will present a series of examples. The first example is 40% of what number is 10,000? The second example will be what is 5% of 8,000? The third example will be 4,000 is what percent of 250,000? And finally, the fourth example will be 15,000 is 12% of what number? For all of these, when I see the word what, I'm going to think of the variable x. When I see the word is, I'm going to think of the equal sign. The word percent simply means divide by 100, and the word of means multiply. Let's go back and translate those. So 40% of what number is 10,000? That becomes 40 divided by 100. That's again for the percent. Of means multiply. What number is x? Is means equal, and 10,000 is simply 10,000. We'll do this for all of the questions before we solve them. What is 5% of 8,000? What is 5% of 8,000? 4,000 is what percent of 250,000? 4,000 is what percent of 250,000? And finally, 15,000 is 12% of what number? Well, 15,000 is 12% of what number? These are now translated into equations, which we will now solve for x, our unknown. X represents different things in each of these questions. It represents a larger number here, and in these other ones it represents a percentage for that one, and it represents a smaller number here. And finally, this question here is actually quite similar to one of our other questions. In order to solve this, I have two fractions, one fraction here and another number here, equal to 10,000. I'd like to make two fractions, so I'm going to put x over 1. When I have two fractions, I can multiply the top numbers and multiply the bottom numbers, and that will equal a number on the other side. And I would like to make this number on the other side also a fraction, which I'm allowed to divide by 1. And from there, I can now cross multiply those two numbers as well as these two numbers. That will give me 40x equals 10,000 times 100. Well, there's 10,000 times 100. I'll just add two more zeros. And then x will equal that number. Divide by 40. Whatever that is, we can work out on the calculator. And that value is 25,000. And so actually what we say is 40% of 25,000 is 10,000. For the next question, I have x equals already. That's quite nice. So all I need to do is multiply 5 over 100 times 8,000. And if I'd like, I can say 8,000 over 1. I'm allowed to do that. That just simply gives me 5 times 8,000 over 100. And again, I can do this on the calculator. And I get 400. And so 400 is 5% of 8,000. For the third one, we have 250,000 here. I'm going to divide that by 1, and then I can multiply my tops and my bottoms. And I'm also going to do, well, let me do that first. So I get 250,000x divided by 100 equals 4,000. And you know what I'm going to do with 4,000? I'm going to divide by 1. Why do I do that? So that I can cross multiply my two fractions with an equal sign between them. I get 4,000 times 100. That gives me 400,000. equal to 250,000 x. And to get x alone, I need to divide both sides by 250,000. And so allow me to do that. We'll divide this side by 250,000, and we'll divide this side by 250,000. That gets rid of these two, leaving me with x alone. And so what do I get? I get x equals 1.6. Let's look up here. 4,000 is what percent of 250,000? 4,000 is 1.6%. So in other words, if I took 1.6% of 250,000, which is the same as 0.016, that 1.6%, times my 250,000. I'll do that on the calculator. I should get 4,000, and I do, and that's simply a check. That's 4,000, and it matches with my other 4,000. Finally, 15,000 is 12% of what number? Well, I'm just going to take my x here and divide by 1 because I'm allowed to do that. I'll multiply my tops and my bottoms. I'll get 12x equal to 100. On the other side, I'm going to make 15,000 a fraction, so I'm just going to divide that by 1. Why do I do that? So that I can cross multiply. And when I cross multiply, I get 12x on one side, and I get 15,000 times 100, which means add 2 zeros. And then to get x alone, I need to divide both sides by 12. Let's see here, we'll do a division by 12 there, and a division by 12 there, and I get 15,000 with 2 zeros, divide by 12, gives me 125,000. So what was the question? 15,000 is 12% of what number? Well, it's 12% of the number 125,000. Once again, there's our table. Please refer to that. And as a next exercise, I would like to go over just a little bit of compounding interest. Here's my formula. I will not explain it in this video. 5,000 invested at 7% for 10 years. What is my new amount? So if I invest 5,000 at 7%, for 10 years, well, my 10 years goes up in my exponent, and my 7% gets tacked on to the number 1. Let me just show you what I did back here. There's my 7%, that'd be R, and there's my 10, that'd be T, and there's my 1 plus the 7%, and P is my principal that I have invested, so 5,000, and you'll know that I ignored the star. Star is something we use for compounding interest, but here, because I'm compounding annually, star equals 1, and so we can nicely ignore star for annual compounding. However, if I were to compound monthly, I would have star equal to 12 because monthly means that there are 12 periods per year which I will compound, so star will equal 12, and you'll see that I'll put that 12 right there in the place of star. 10 years, same 10 in the exponent. 7% interest rate, still there where R was, and 5,000 as my initial principal remains there. I could have asked the question with depreciation. I have a $5,000 car, for example, that depreciates at 7% annually over a period of 10 years. And what is the current value? Here I would simply use the same formula, but I would subtract my percentage. I would not add it, I would subtract it to show the depreciation. And finally, we could have also solved for the amount that we needed to invest originally, P. If we ask the question, how much money needs to be invested at 7% for 10 years if we wish to have $20,000 at the end. Well, I didn't make any specific case here. I could have said compounded, and now we have to pick how often we'd like to compound it. Let's just say we're going to do monthly. And that means that star equals 12. And now I'm going to solve for P. And so P is going to equal, quite simply, well, my 20,000 in the top. And I shall divide by all of this right here. I know that's a fairly complicated number from first sight, but with a calculator, it should work out quite nicely. And so allow me to do that on the calculator and give a result. And the answer I get is 9951, 93. There's actually a bit more accuracy to the number, but because we're dealing with money, I will round to the nearest centime or penny or cent. So I need to invest $9,951.93 at 7% for 10 years if I wish to have $20,000 at the end of that time period. I hope that helps. If you have any questions, feel free to contact me.